Consider a case where we have a source of sound. It's emanating sound in all directions, but it is stationary, so it's not moving at all. The waves would travel away at a standard velocity of sound, in air, maybe 340 meters per second or so, and they'd have a standard wavelength. Okay? Now, what if I, as the observer, here's my ear, I am moving towards the source with some speed greater than 0. I'm moving towards the source. What do I perceive? Okay. Now in this case, as I'm moving into these wave fronts, I'm moving through a certain amount of air that is no different than the air that's in between these true wave fronts from the stationary source. And so I'm running into these faster than they would have gotten to me before. I have a relative speed between these wave fronts moving and my ear, based on the fact that my velocity is moving into it. And so to do that, we say, well, what's the perceived velocity? What velocity do I perceive these coming? And it's going to be equal to the velocity equal to the velocity that they're traveling plus the velocity I'm moving into them. So they're coming at me faster because I'm moving into them. Okay, so that's going to be plus V observer. Okay, so this is the perceived speed, and this is the speed of sound in air and my speed. Now the wavelength is the standard wavelength. Okay, the velocity that they're traveling air is given here, but the thing that is perceived as different is the frequency. So though I'm going through the same amount of air, giving the wavelength being the standard wavelength, I am seeing these at a greater frequency. So I can rewrite this as velocity equals lambda prime times frequency prime, but my wavelength is the standard wavelength. So I'm going to divide down by that wavelength, so I'm going to get velocity plus velocity of the observer divided by the standard wavelength. It's the true wavelength because there's the same amount of material in between it, whether or not I'm moving into it. But I do perceive a change in frequency. So looking at this standard wavelength and knowing that it's related to the original frequency and the true speed, I can now write this as f prime is equal to v plus the observer over velocity in air over the true frequency, unprimed, which leads me to be able to write f prime equals the true frequency times v plus the observer over v, the speed of sound. So this now gives me the perceived frequency if I am moving towards a source. And it is different. It is different than if the source is moving towards me, which we'll do that comparison in a little bit. But before we leave this, let me point out that we derived this for the object moving towards or approaching this, or the observer approaching the source. And we ended up with a positive sign here because that was the increase in speed, the perceived speed. And so we can have a convention saying if the observer is approaching the source, then we plug in a positive value here. If the observer is receding from the source, we plug in a negative value here. So we have v plus a negative value. And that will be consistent for both cases.